Sorry about that. All right, so here we go. We're going to take a look at these rational inequalities, polynomial and rational inequalities. We're going to do it visually first. This first one has our functional value. Where is it greater than or equal to 0? So if you notice, it's right at 0 right there at those 2 points, and then it's above it, greater than or equal to, after 5. So we know 5 will be included in anything after that. And I'm naming my solutions in terms of the x values. And I also know that negative 2 right there is also part of it because it's or equal to 0 right there. Now for the next part, I'm just looking, where is the functional value less than 0? I got to be below it. So if you notice, I'm below it here. I do touch it at 0, but I want to be below it anywhere in green. So I say, well, from negative infinity up to negative 2, but I can't touch negative 2 because I got to be below the x-axis, right? And then I take off again from negative 2 up until 5, but I can't include the 5 either because I got to be less than 0. So I name the solution set in terms of the x values, right? Let's do another one here with the next graph. This one is where is the functional value greater than 0? Strictly greater than on this one, not greater than, it's just strictly greater. Where am I? Above the x-axis, in other words, right? So I can see that on the graph here in blue, I'm above it until I hit right here at negative 3, and I actually hit it right there, right? So from negative 6, no, notice I have a vertical asymptote at negative 6. So I'll never touch negative 6. From negative 6 up until that negative 3, but I can't touch negative 3. And then also over here, I'm above it. So I'm above it that whole time over there on the right. Because notice I have two vertical asymptotes here. I have negative 6. I also have a vertical asymptote at x equals a half. So it takes off again after a half and keeps going. All of those are positive. So that solution set, that's saying all the x values for which f of x will be greater than 0. Does that make sense, you guys?
Is it 3 or negative 3?
Yeah, thank you. That is negative 3. Sorry about that. That's a negative 3 right there that hits it. Thank you. All right, so the second part, where am I less than or equal to? So again, we know we hit right there at negative 3, and then we're down below. So from negative 3, I do hit. I'm going to include negative 3 because I'm or equal to, up until an x value of a half, but I don't include a half. That I'm less than or equal to. And then notice over here as well, from negative infinity up until negative 6, I'm not going to touch negative 6 because it's a vertical asymptote. So those are my two spots for which f of x is less than or equal to 0. And now we're going to do it algebraically instead. Okay. So this one, I'm just going to do the numeric. What's it called? Instead of the table method, the line method. Okay. But I can kind of walk you through if you're interested in the table method and what it's talking about as well. But when you're doing these things algebraically, okay, they're asking for what x values is this true, right? The first thing you want to do is you want to find what's called your critical points. Your critical points are your zeros and where it's undefined. So for a minute, I know it's asking us where is this less than 0, but let's answer this question. Where is that equal to 0? And we say, well, we know for 5 and for negative 2, right? And so I would put those, for my number line method, I put those on my number line, 5 and negative 2. And then I got to decide if I can include those as part of my solution. So here's my question. Where's this less than 0? So let's test the critical point -2 first. So I throw -2 into that. And then I ask the question, is 0 less than 0? Is that true or false? You say, well, of course, that's false. 0 is not less than 0. So I cannot include -2. So I'm going to leave that as an open hole right there, meaning I'm not going to include -2 as part of my solution set. And then I'm also going to test my other one at 5. I'm going to test that critical point as well. So I throw it in as well. Zero times whatever, 0 is 0 less than 0. Again, you have a false, right? So if you have a strictly less than, not a less than or equal to, your zeros are not going to be included in the solution set. Now we got to determine, well, what about to the left of -2? What about between them? And what about to the right of them? Well, you're just going to test points to see if it's true or false. So we're going to test something to the left of -2, like maybe -3. And we're going to throw it in to this again. So we have -8 times -1 squared. Well, -1 squared is +1, so it's -8 times 1, -8 less than 0. And you say, well, that's true. So I know part of my solution set's from -infinity up to -2. That'll make this statement true. Now I'm going to test something between -2 and 5. So let's test, like 0 would be a good one. So let's throw 0 in. 2 squared 4 is -20 less than 0. And I'm like, oh yeah, -20 is less than 0. That's also true. And finally, let's test something out here to the right of 5, like 6. Is 64 less than 0? Definitely not. That's a false statement, right? So this is showing us our solution set. Our solution set's going to be from -infinity up to -2. Do not include -2. We cannot include that critical point -2. And then it's okay also between -2 and 5. Everything will make that true as well, but after 5 it's false. And so that would be our solution set. Now I don't do the table method, but if you did, you're throwing in, it's saying pick something less than -2, like -3, -3 minus 5. You get a -3 plus 2 quantity squared would be a positive, all right? Negative times a positive is a negative less than 0, and that's true, right? So you end up with that being true. And similarly for the rest of that, you plug in 0 minus 5 negative, 0 plus 2 squared positive is a negative times a positive is a negative less than 0. Yes, it is. And finally, you do the last one is a positive number less than 0, and no. So I don't like to do the table method. I'm only going to do the number line method with you guys. Because that's typically the best, in my opinion, way to solve that algebraically. I do want to show you graphically how this connects. This is the function. If I was to name the function y equals x minus 5 times x plus 2 squared, and then I'm just trying to see where that's less than 0, right? Let me just throw it into decimal so you can kind of see that. And can you kind of see how you're coming from -infinity up to -2, but I got to be less than 0, so I can't include -2. Again, I wish I could draw on this decimals, but I can't unless I rip that image. But anyways, and then from -2 to 5, see how you're below less than 0 on that. So the algebraic does connect, obviously, to the visual for these rational inequalities. Let's do another one here. Notice on this one, I don't have one side as a 0. So before I even start this, make that one side equal to 0. So I'm going to go ahead and subtract 5x on both sides and subtract 6 on both sides. So this is really the question. Where is 6x squared minus 5x minus 6? Where is that less than 0? And then I would go ahead. So that's our question here, right? I go ahead and factor that. Let's see, what would that be? Plus 2 minus 3. 3x squared minus 9x plus. Oh, whoops, that's a 2x right there. There we go. 6x squared minus 9x plus 4x minus 6. There we go. Okay, so my critical points, I'm imagining this equaling 0, right? So minus 2 divided by 3 divided by 3. So I got negative 2/3 from that one, and I got a positive 3/2 from that one. These are my critical points, my zeros. So my critical points are anywhere where this is equals 0 or undefined. We haven't done an undefined situation yet. Okay, we have to decide, will I include these points as part of my solution first? Before I start testing intervals, I have to decide if I'm going to include them. So I throw negative 2/3 in. Right, I'm testing it into here. So I have 3x plus 2, 2x minus 3, is that less than 0? Well, 3 times negative 2/3 is negative 2. So I got 0 from here, right? That's going to give me negative 2 plus 2 is 0. Times over here, I got negative 4/3 minus 3. So 0 less than 0, again, false, right? It's strictly less than. So I'm not going to include that. Right? Because this is, again, strictly less than. It's not an or equal to. I'm going to throw the 3/2 in. It'll give me a number times 0 is less than 0. Well, again, 0 is not going to be less than 0, so I'm not going to include those. Now I got to make sure I write out the testing interval part. So let's test something to the left of negative 2/3, like maybe negative 1. So I got 3 times negative 1. So I got negative 3 plus 2. I got negative 1 times negative 2 minus 3 is negative 5. Is 5 less than 0? And you say, nope, false. Test something in between them. Maybe zeros between them. So I got 3 times 0 plus 2. I'll say, oh yeah, negative 6 is less than 0. So in between them is definitely a solution. And then I'll test something to the right of 3/2. Like maybe 2. Just to the right of 1.5. So like that's false too. So false, true, false. So my solution set is just in between them, right? In between negative 2/3. Do not include negative 2/3 up to the 3/2. Do not include the 3/2 either, because we determined that those critical points could not be part of our solution. All right, you know what? Why don't you guys try this one? And before you do, make sure you get one side equals 0. But let me pause this. Have you guys kind of try this one. All right, we'll check you to there, at least for the critical point. So I added 15x squared both sides. Find my zeros, so 0, -5, I throw them on. I got to decide whether I can include my critical points because I'm asking for this equation, right? So can I include -5? Well, 3 times 25, what's that, 75, but that's 0. Is 0 greater than or equal to 0? True or false? True, yeah. So, okay, so -5, we can actually include -5. Again, notice it's an or equal to. So the other 0, when I'm testing 0, oops, that'll also be true. That's also true. So I can include the 0. Now I got to decide if I can, now I got to test my intervals, right? So I test like -6. I test maybe -1 and maybe 2 over here. And I'm just testing it in this 3x squared times x plus 5 greater than or equal to 0. Or the original, right? Either one. Also plug it into that. So 3 times -6 squared. So we have 3 times 36 times -1. Well, that's a negative number. Is that greater than or equal to 0? Is a negative number greater than or equal to 0? Yeah, you say false, right? That's false. Let's try -1. So we got 3 times -1 squared, that's 3. -1 plus 5, 4 is 12. Whoops. Greater than or equal to 0. That's true. 12 definitely is greater than or equal to 0. Now let's try 2. Three times 4, 12. 2 plus 5, 7. 84 is definitely greater than or equal to 0 also. So our solution is -5, include -5, up to 0, right? So -5 up to 0 includes 0, but then we go from 0 on again and we're including 0. So instead of having a break there because we're including it, you just say, oh, -5 and on, right? Don't write it that way because I include that 0 there. So -5 on. All right, let's do one now where we have a critical point that's undefined in this next one. Pause that if you need to still write any of that, but let's go to this next one here. When we're analyzing, notice that I have a 0 on that one side, on the right-hand side. So let's talk about our critical points. Our critical points are our zeros and where it's undefined. Well, our zeros come from the numerator, right? So we have 2 and -1, and then it's undefined. If this was y equaling this function, I'd have that vertical asymptote at 4, right? So these are all my critical points, 2, -1, and 4. So -1, 2, and 4. Now, 4 is undefined. So I know when I test it, it makes the whole thing undefined. So there's no way I can include the 4, right? And then the 2 and the -1, I could throw those in, right? I could test like -1. Let me throw that in. And you'll notice I get -3 times 0 over -1 minus 4, -5. I got 0 over anything 0 is 0 less than or equal to. Again, we have an or equal to. So it's going to include the zeros. It's going to include that. So I got to fill that in. And when I plug the 2 in, it's going to do the same thing. It's going to give me a 0 less than or equal to 0. So I'm going to include that. So now I just got to test these intervals. So I got to test to the left, like maybe -2, something between them, like maybe 0. between 2 and 4 would be 3, and then test 5. All right, and I'm testing it in this original x minus 2 times x plus 1 over x minus 4. Is this less than or equal to 0? Let's throw negative 2 in. Well, I got a 4 over negative 6. So a negative 2/3, is that less than or equal to 0? I say, sure it is. True. Now let's throw 0 in. 0 minus 2, 0 plus 1. So half less than or equal to 0, that's a false. Now let's try 3. Four over negative 1 is negative 4. It's negative 4 less than or equal to 0. That's true. Now let's finally try 5. Three times 6 over 1 is 18 less than or equal to 0. That's false. So it looks like our solution set will be from negative infinity up to negative 1. We can include the negative 1. And then it'll be from 2. We include 2 up to 4, but we cannot include 4. Remember, 4 makes that thing undefined. Right? So that'll be our solution set for that one. All right, let's do our critical points first on this. It'll be our zeros. The zeros come from the numerator. So 2, negative 2. So notice I have 2 and negative 2. And, you got to decide if that'll include them, but notice it's greater than 0. So when you plug in 2 or negative 2, like if you check either 2 or negative 2, what you'll get is 0. Is 0 greater than 0? No. So you can't include either of those because it's a strictly greater than. And then the other part of it is, where is it undefined? The other critical point comes from the denominator. So 3. You'll never include an undefined point. So that's an automatic exclude that point at 3. Okay? And now let's go ahead and start testing our intervals. So we'll test to the left of negative 2. So maybe negative 3 into our original x squared minus 4 over x minus 3. We're going to see if that's greater than 0. So we have 5 over negative 6. Is that greater than 0? We say false. Let's test between them. Maybe 0. Is 4/3 greater than 0? That's true. Oh, this one's a little awkward. I'm going to have to do like between 2 and 3, 2.5, so like 5 halves. So I got 25 over 4 minus 4, which is 16 over 4. This is all over 5 halves minus 3. Well, 5 halves minus 6 halves is negative 1/2 on the bottom. And I got 25 minus 16. I got 9/4 over negative 1/2. Well, that's a positive over a negative. Is a negative greater than 0? You say it's definitely not. In other words, negative 18/4. Is that greater than 0? No. And now let's test something out here, like 5. Or 4, I guess. We'll do 4, just to the right of 3. You could do 5 again, doesn't matter. As long as you're to the right of 3. So we got 12 over 1. Is that greater than 0? Yes, it is. True. So we got false 2, false, true. So let's name our solution set. We're between -2 and 2. Cannot include -2, cannot include 2. And then to the right of 3, cannot include 3. Couple more here. So this one, notice on this one, now if I'm looking at this one, the problem with this is I don't have one side equal to 0, right? So the first thing I got to do is take that 1 over. So I get x plus 2 over x minus 4 minus 1 greater than 0. Now, I need this to be one fraction. So let me put that over 1. Let me get a common denominator of x minus 4. And then this will become x plus 2 minus 1 times x minus 4 all over this common denominator of x minus 4 greater than 0. Now let me distribute that. And now notice these x's cancel. So I have 6 over x minus 4 greater than 0. That's our question right there. All right, that's what we're questioning. So what are my critical points? Well, I don't have any zeros. I only have where this thing is undefined from the denominator. It'll be undefined at 4. All right, so when I'm testing this, I have a 4 on there, and I know there's no way I can be that because it'll make it undefined. All right. So now I just got to test around it. So let's test like 3. Let's throw it in. Six over -1 is a -6. Is -6 greater than 0? Nope. Test something to the right of 4. 6 over 5 minus 4 is 6 over 1. Is 6 greater than 0? And you say, you bet it is. So our solution set is just from 4 on. 4 can't include 4, but we can go on after that. All those will make the original inequality true. All right, this next one we've got, notice a less than or equal to 2. So I got to take that 2 over. I got to subtract 2 first. So let's go to that point. Subtract 2. So now we're less than or equal to 0. Now right now this is 2 over 1. So I got to get a common denominator so I can put these two together. So this will become 2x squared plus 3x minus 4 minus 2 times x plus 1. Now it's all over that common denominator of x plus 1 and will be less than or equal to 0. So now I got 2x squared plus 3x minus 2x, so plus x. And then minus 4 minus 2, so minus 6. So we have 2x squared plus x minus 6. Well, that'll factor. Let's see, minus 3 plus 2. Let me check that. 2x squared, 4x minus 3x. There it is. Okay, so this is what we're asking. This is a useful form, right? Right there. So then I say, okay, well, my critical points are from my zeros. Which are from the numerator. So 3 halves and -2. And where's it undefined? This is my other ones. Well, the denominator can't be 0, so -1. So I know when I draw this, -1 will not be included. It's undefined there, so definitely throw that out. -2, I got to think about that one for a minute, and then 3/2 is my other one. Okay. Now my zeros, the question is, will they be included? Well, if I throw in like -2, that'll be 0. So I'll have 0 times whatever over 0 over whatever, right? Which is 0. So is 0 less than or equal to? Again, this is or equal to. So yeah, so that's true, exactly. So that'll be true. If I throw in the 3/2, that'll give me a 0 as well. Is 0 less than or equal to 0? Yeah, so the zeros will be included on this.
So the denominator have to be 0?
So now we'll test some points, like -3, and I'm throwing it in. 2. So I get 2 times -3 is -6. -6 minus 3 is -9. -3 plus 2 is -1. -3 plus 1 is -2. Well, that's a +9 over -2. That's a -9/2. Is that less than or equal to 0? Yes, it is. Now let's test something between -1 and -2, like -1.5. -1.5, so -3/2. So I have 2 times -3/2 minus 3. I got -3/2 plus 2. This is all over -3/2 plus 1. Well, 2 times -3/2 is -6 over 2. That's -3 minus 3. That's a -6. -1.5 plus 2. So -3/2 plus 4/2 is a 1/2. -3/2 on the bottom plus 1. -3 over 2 plus 2 over 2 is -1/2. So I have a negative over a negative here. I have a -3 over -1/2, which is a +6. Is that less than or equal to 0? False. No. 6 is not less than or equal to 0. I could pick something between -1 and 3/2. I like to pick 0 if I can. So I have 2 times 0 minus 3, that's -3. 0 plus 2 is 2. 0 plus 1 is 1. So I have -6 over 1. Is that less than or equal to 0? True. And finally, let's pick something to the right of 3/2, like 2. So I have 2 times 2x minus 3. So I have 2 times 2. 4 minus 3 is 1. 2 plus 2 is 4. And then on the bottom, I have x plus 1. 2 plus 1 is 3. Is this less than or equal to 0? Is 4/3 less than or equal to 0? That's false. So then our solution set is -infinity up to -2. I include the -2. And then do not include the -1, but then I include the 3/2, right? So let's write that out. -infinity up to -2, include the -2. Let's include. And then from -1, but I cannot include -1, up to 3/2. And that's it. Thanks for watching.